In this lesson, we will be solving and graphing quadratic inequalities. Step 1, make it into an equation. So as you can see, x squared minus x minus 12 is greater than 0. We're just going to replace greater than with equals. Step 2, we're going to solve. I want you to solve this equation using any method possible. That's factoring, if it's easiest, completing the square, or quadratic formula. Here we're going to factor. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So this is how we express our factored equation. X minus 4 times x plus 3 equals 0. And the solution set is 4 and negative 3. Next step, we're going to plot our points, negative 3 and 4, the solution set, on a number line. We're going to use open dots because this is greater than, there's no equal to piece to it. So that's why it's a hollow or open dot. And we're going to divide up our number line into 3 regions. Right, here's a vertical line here, vertical line here. We're going to test each of these intervals out by choosing a test point and plugging it back in to the inequality. So you want to choose any number here that's less than negative 3. Well, I recommend choosing the number that's closest to negative 3, that's less than it, and that would be negative 4. So let's plug negative 4 back into this factored form of our inequality. So we're going to plug in negative 4 minus 4 times negative 4 plus 3 is greater than 0. I want you to put the inequality back in so we can test this out. What's negative 4 minus 4? Negative 8. Negative 4 plus 3 is negative 1. What's negative 8 times negative 1? It's positive 8. Is positive 8 greater than 0? Yes, it is. This is true. Let's now choose a test point that's between negative 3 and 4. Well, the easiest number to use is 0. So if we plug in a 0 here for x and plug in a 0 here for x, we'll end up with this inequality. And negative 4 times 3 is negative 12. Is negative 12 greater than 0? No. False. Finally, we're going to choose a test point for this interval. We'll choose 5. So we have 5 minus 4 times 5 plus 3 is greater than 0. 5 minus 4 is 1. 5 plus 3 is 8. And 1 times 8 is greater than 0 is a true statement. So, ladies and gentlemen, we are going to graph our solution set this way and this way. Okay, put your arrowheads here, showing that the graph, the solved number line looks like this, right? This is the solution to the number line, or the solution to the inequality. This is the graphical way we look at this. Now, the final part is to write the solution as a compound inequality. What I suggest is you actually write down negative 3, you write down positive 4. And then you think about, where is the solution? Well, the x's that work for this inequality are all to the left of negative 3. In other words, they are less than negative 3. So we have x is less than negative 3. And because this is a disjunction, we use the word or. And over here we have x is greater than positive 4, just like this. Now you could have written this 4 is less than x. That would have worked too. Okay? So there it is, all put together. This is your final answer, your compound inequality, your graph number line, and your solution set to the equation, which is really the inequality. Okay, just wanted to show you this next one. Make sure that you put your inequality in standard form first. You see how we subtracted 8 from both sides, giving us x squared minus 2x minus 8 is less than 0. Replace that less than with the equal sign. Factor, solution set is 4, negative 2. Plot your points. Choose your test points. And this time it's a conjunction. The the solution is right here between the 2 points, the 2 roots. Okay, the last example we're going to look at, we're going to confirm with the graphing calculator. So first step, replace the inequality with an equal sign. Factor and solve is the second step. We have -5 and 1 as our solution set. Because we have this greater than or equal to piece, we're going to use solid dots. So now we have -5 and 1. Our interval that we're going to test here on this side, we're going to use -6. When we plug in -6 to the factored equation, we end up with 7 is greater than or equal to 0, which is true. When we plug 0 in, we end up with -5 is greater than or equal to 0, which is false. And over here, the number that is closest to 1, that is greater than 1, is 2. So we'll plug 2 in, and we end up with 7 times 1 is 7, which is greater than 0. That's true. So we're going to graph this disjunction, and our compound inequality is x is less than or equal to -5, or x is greater than or equal to 1. Now this is the part I was talking about where we will plug this equation, right? You want to plug it in as an equation, x squared plus 4x minus 5, and you want to graph the parabola. Here's your parabola, and I want you to take notice that the roots are consistent. Here's -1, 2, 3, 4, 5, see -5, and +1. Now, think back to what the question asked. The solution set for the inequality, x squared plus 4x minus 5, is greater than or equal to 0. Where? So where is this parabola greater than 0? In other words, where is it above the x-axis? If you think of this as the water line, 0, sea level, where is the parabola underwater? Where is it above water? Well, it's above water at 1 or greater than 1, and it's above water less than or equal to -5. So this right here is consistent with the number line that we graphed over here. Okay? So that's how you put the graphical to the algebraic. I hope you understood this lesson. Best of luck to you.